calculus. Maximum minimum word problems. What we want to discuss today is to find the maximum value or a minimum value of a function, and also to find at what particular value of the variable so that the maximum or minimum occurs. Let's have an example so that we can understand the question completely. So this example is that I have a circle. I have a circle, and I want to draw a rectangle inside the circle. How do I draw the rectangle so that the area of the rectangle is maximum? There is a condition that the diameter of the circle is given to you. Okay, so let's have a diameter. The diameter is 10. Now let's draw a rectangle. So I draw a rectangle. This is any rectangle as long as the four corners touches the circle. So, and from one corner here to the opposite corner, this is the diameter. And the diameter is given 10 units. How do I draw the rectangle? In other words, let me call this side x and side y. How long is x and how long is y so that the area is a maximum? If this is x, this is y, then from Pythagoras theorem, so I have x squared plus y squared equals 10 squared. Pythagoras theorem. And 10 squared is just 100. Okay. What is the area of the rectangle? The area A, of course, is length times width. Length times width, which is xy. I want to maximize the area. But I have two variables here, x and y. So I need to eliminate one of the variables so that I can express the area in terms of only one variable. And as long as I have one variable, then I can find the maximum area. So how do I eliminate? I can eliminate x using this relation, or I eliminate y using this relation. Okay, let's eliminate y from this. Let's call this 1. And let's call this 2. From 1, I have y squared equals 100 minus x squared. Therefore, my y is square root 100 minus x squared. This is my 3. I substitute 3 into 2. Then I have the area equals x times the square root. So this is my area. So my question is, I want to maximize the area. Okay, first of all, let's do this. Let's do a table values. So I give x a certain number, and from that I can find the area. So I have a table which is I have areas which is area. Oops, okay. I should write this way. X I assign x a number and I can find a. So I give x a number and I can have a. Okay, let's this is done, and I just copy down the table values. So the table values, if x is 0, then the area is 0. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3. I have to continue the table values. 1, 2, 3, 4, 5, 6, 7. Okay, I continue my table values. Eight, 9, 10. I cannot have 11, you see, because if I have 11, 100 minus x squared becomes a negative number. I cannot square root a negative number. So the largest x allowed is just a 10. Largest x value allowed is 10. So this is not allowed. When x is 0, this is 0, a is 0. When x is 10, this is 10, this is 10, but 10 squared is 100. So 100 minus 100 is 0, so it's again 0. You see something? If x is 0, area is 0. If x is 10, the area is 0. So between 0 and 10, the area looks like there is a maximum. And if you really put the numbers in and calculate area, I have the following table. This is already done, so I just put this down. 9.9, and you see the area becomes larger and larger as x increases from 0. So this is my table of values. Now from the table of values, you can draw a graph. And this is exactly what we are going to do. So I need another piece of paper. From the table of values, I draw x as a horizontal axis, and the area is my y-axis. So I'm not drawing this according to scale. It's difficult without grid paper. So from when x is 0, the area is 0. The area is 0. When x is 10, the area is again 0. So I have 2 points. And between 0 and 10, I have, if you really draw the graph according to the table values, it looks like that. It looks like that. So there is a maximum value. And when x is this value, I have the maximum area. Now, if you draw this graph accurately, according to the table values, draw this accurately, you can find this number from the graph, and you can find this number from the graph. So I do not have an accurate graph, so I'm not going to do that. So let's do this using calculus. So I start from area. I start from the area. Area is x times the square root 100 minus x squared. So I do the derivative. You see, at the maximum value here, at the maximum area, the tangent is horizontal. Then the slope of this line is 0. But calculus tells us that the slope of the tangent line is the derivative. So the derivative, because the y-axis is a, the x-axis is x, So the derivative is dA by dx. This is the derivative. If the slope is 0, the derivative must be 0. So I do that. dA by dx. Now this is u, and this part is v. So the derivative is product rule, u prime v plus v prime u. That is the product rule. So I use the product rule. What is u prime? The derivative of x is 1. So I don't need to write 1. Then multiply v. Okay. Plus v prime times u. The v prime is this. What is the derivative of this? First, I have the exponent, which is 1/2. And then 1/2 has to subtract 1. So one half subtract 1, 1/2 subtract 1. And then multiply the chain rule. Chain rule is the derivative of inside is negative 2x. Okay, this is my derivative. So I arrange my terms, simplify it. Look, this 2 and this 2 cancels. I have a minus here. So I have a minus here. Oh, this is v prime. V prime times u. U is x. So I forgot times x. So this part from here to here is v prime and v prime times u. So 2 and 2 cancels. I have a negative. I have x squared here. This is the denominator. So I have x squared here. And 1/2 minus 1 is negative 1/2, which means this goes to the denominator. Negative 1/2 is square root in the denominator. So this is my derivative. And I want this to be 0. Which means this is equal to that. Then you reduce it. So you multiply this to the left-hand side. So I have square root of this times the same square root. So square root disappears. I have 100 minus x squared equals x squared. So this means 100 equals 2x squared. That means x squared is equal to 100 divided by 2, which is 50. So x is square root 50. Square root 50, you can write this as 25 times 2. And this is square root 25 times square root 2. But square root 25 is 5. So I have x is 5 times square root 2. I want the dimension of the rectangle. So I have the x already, so I need y. So y is what? Y is, from where can I find y? Okay, so let's see this now. Y is square root 100 minus x squared. So y is equal to square root 100 minus x squared. But x squared is 50, so that means it's square root 50. But here I have square root 50 here, so which is 5 root 2. So what I have is that x and y are the same. So x equals y equals 5 root 2. That means it is a square. This tells me the rectangle is a square. This is a square. What is the area? Area is x times y. And a square, the area is x times y. So 5 root 2 times 5 root 2. So it's 5 root 2 square. So what is that? Five square is 25. Root 2 square is 2. So 25 times 2 is 50. So the maximum area is 50. And the rectangle is a square. So that is this question. I have shown you every step in detail, so I hope you follow that. You see, this is, let's make a summary of this. So if you have the question, so first of all, you write what you want to maximize. In this question, it's the area we want to maximize. Once you have the variable in the diagram, oh, by the way, it is best to draw a diagram first, draw a sketch first. And then you give some variable in the diagram. So in this question, the area is xy, contains 2 variables. So you must eliminate one of the 2 variables. So x and y are related by the Pythagoras theorem. So use the Pythagoras theorem to eliminate y. Then your area is a function of x only. Once you have that, and in order to understand better this question, let's graph it. So I do a table values, and you graph it. So from the graph, you indeed find the area has a maximum value. And if you draw the graph accurately, you can find the value from the graph. But we need to do algebraically, so we do calculus. And this area is a product of two parts, so we use product rule. And step by step, we can find x. And then once I have the x, I have the y. So to find the maximum value of the area, I need the derivative of the area with respect to x, dA by dx, and I let it be 0. So this condition, the derivative is 0, is because at the maximum value of A, at the maximum value of A, the tangent to the graph is horizontal. A horizontal tangent means the slope is 0, and the slope is 0 means the derivative is 0. So that's how we do this problem. And finally, we discovered that the rectangle is a square in order to have the maximum area. So that is how we do this. We need to do more examples so that we can understand how to do this kind of maximum minimum problems. So this is the first part, and in the next lesson we will do the second part. Thank you for watching, and goodbye.